Welcome back. I hope you all enjoyed your break. And I know this is an exceptionally long class, and I know it's difficult to stay focused. So thank you for being here, and thank you for your attention. Yeah, so I was here on Monday, I think you remember. And so now I want to talk to you a little bit more about musical robots. And I want to try to give you a more broad overview of some of the research that's been done pertaining to musical robots and how AI has been used. And so I think up until this point, a lot of the lectures that you've heard have focused on algorithms or machine learning techniques. And so today, well, now what I'm going to talk to you more is like an application area for some of those algorithms. So if you've been learning about the hammer, I'm going to talk to you about the nail. Okay. And I just want to start by pointing out maybe that people have been building these humanoid musical machines for thousands of years. Okay, so this is by no means a new undertaking. And even though artificial intelligence, as we understand it in the context of this class, is only maybe a few decades old at most, still when you look at the literature from this time period and you see the way people write and talk about these types of musical machines, people very much ascribe a type of intelligence or a type of lifelikeness to these machines in a way that feels like very modern. Yeah, so I think people have been using musical machines to fantasize about artificial intelligence and artificial life for a very long time. And yeah, maybe I'll make one more brief point about that, which is that machines like this are not just kind of sidelines in history. They're not just novelty devices, but quite often when you look through history, you find whenever there's a critical junction in the history of computing machines, or like a critical junction in the history of the development of intelligent machines, you often find that machines like this play a key role in that history. And I actually think that there's something special about music. Music has a special relationship to intelligence, and music also has a special relationship to machines. So often when you're trying to bridge the gap between machines and intelligence, I think it's no accident that music is not too far away. And so maybe I'll spare you a major history lesson for now, but if you're interested more, maybe you can ask a question at the end, and I can go on and on and on about this. But for right now, I just want to kind of dive into some more modern robots. Well, 1985 is not that modern, but it's more modern. And so this musical robot was developed in Japan. Yeah, and I think it was kind of developed in 1984 and 1985, and it plays this digital organ. So you see it has this keyboard, it plays with its hands. And then down here, there's also a pedal board, so it can play notes with its foot. And yeah, so some of the things that this robot does. So first of all, this robot can speak and understand spoken Japanese. So it uses speech synthesis to speak and speech to text, kind of to understand spoken speech. And you know, of course, today this is something we take for granted because we all have computers that do this, and the operating system does it, and we don't really care how it works. But you know, you remember in 1984 was the year that Apple Macintosh first came out. So the personal computer barely even existed. And in Japan, they had a robot that could speak and understand Japanese. And so the idea is that this robot, first of all, would have several songs pre-programmed into it, and you could request a song just by speaking the name of the song that you want to hear. So something else this robot could do is it can follow a singer. So it was designed to play this instrument in accompaniment, like with a singer singing a melody. And because the robot knows what notes are supposed to be sung, the robot basically at each moment in time, it's waiting for the singer to sing the next note before playing the accompanying chord. So in other words, yeah, this robot the singer can sing at any tempo. They can go as fast as slow as they want, and they can speed up and slow down as they want as they're performing, and the robot will follow that. And that is, yeah, also similar to how human accompanists accompany a singer. Although, just maybe briefly, it's interesting to think about how the way humans do it is different than how this robot does it. Because when a human pianist is playing with a singer, the pianist is not just listening to the singer, but also watching the singer, right? So there are like visual cues. You often wait for the singer to breathe, or you see the singer make some gesture that indicates that they're about to start singing a note. So it's interesting to think about how you might make a robot use this kind of multimodal way of interacting with a human by watching and listening, and maybe doing something anticipatory rather than just waiting and then trying to react to that. And then just briefly, one more thing that this robot can do, and this absolutely blew my mind when I learned about this. That robot can actually read printed sheet music. So if you have one page of score, and it has to be one page, there's no provision for turning pages, but you set one page of music in front of the robot, and it takes about 7 seconds to analyze the whole piece of music. And yeah, then it can play it. And the sheet music, basically it has right and left hand part for the robot, and then the foot part for the robot, and optionally a vocal line for a singer. And they claim that this works with about 100% accuracy. Although I should maybe also note that they're also only using children's songs. So a one-page children's song. But yeah, so regarding how they do this, I mean, like modern image processing techniques didn't exist in 1985. So from what I understand, based on Google Translate, is they're using some kind of template matching system. So you can search the score for like these 5 parallel lines. And once you've found 5 parallel lines, that kind of gives you some idea of what it anchors you, right? It tells you where the other symbols are supposed to be relative to the page. And then you have this library of templates, and you take some template and you kind of move it around the score in the area where you think that symbol might be. And you try to see if that score is there, or you try to see if this symbol is actually there or not. And I think ultimately the algorithm that they use to do that is, image convolution. You convolve the template with the score to see if the symbol exists or not. And of course, today you would almost certainly use a convolutional neural network for this type of image analysis. And I'm actually not sure what state of the art is right now. Somebody must have made a system where you can scan a piece of sheet music and get a symbolic representation of the music, but I'm not sure what that is. But that might be an interesting thing to look into if somebody wants to do something like this for their project. Try to figure out what state of the art is and see if there's any room for improvement based on modern machine learning techniques. Yeah, okay, and then I have just a little video of this robot playing some music. I couldn't find a video that really shows it like reading a piece of music or following a singer, but I'll at least play this for you just so you can see kind of what this looks like. Okay, that's all. The whole video is on YouTube. You can watch it. Yeah, so I forgot to ask. I just wanted to ask if any of you actually play instruments. Show of hands. A few of you. And yeah, are any of you, or maybe are there some of you that don't play instruments that like just in general think that you might someday consider music to be like a research topic? No, okay. Anyway, so yeah, I want to tell you about a different robot now. And so I think you can see this is a flute playing robot. This is a real, German orchestral flute. And this was actually developed at the same university as the robot that I just showed you. And they've been working on this for quite a few years, 30 years at least. I'm actually not sure if they're still actively working on it. The last paper I found was in 2010, but yeah, quite a nice robot. So it has these kind of bellows in its lungs that it uses to expel air out of its mouth. And then the mouth has a few degrees of freedom. So it has these kind of like soft lips, and it has some actuators in there that it can use to, so the air is coming out of its mouth in a beam, and so it can kind of control the speed and angle of the beam of air. And then it also has, obviously, its arms and fingers can move to depress the buttons on the flute. And this is one of those things that, of course, they've done tons and tons of things with the robot over the years. But I just want to focus in on one way that they've used machine learning in this robot. And I want to show you first an example of some human playing the flute. And it's maybe interesting to watch this and to think about like what some of the challenges would be, like if you were going to build a robot to do what this person is doing, just like very broadly, what do you think some of the challenges would be? When I play this, actually, there's just one thing I want you to focus in on. And before I play it, I just want to show you this. So this is actually the piece of music that he's going to play. And I recognize that that's completely illegible. It doesn't matter. But the thing I want to point out is that all of the notes in this piece of music are the same duration. Okay, so the rhythm that's written here is so just every note is exactly the same duration as every other note. Okay, but despite the fact that that is what's written here, what you're going to hear the performer do is continually speed up and slow down. Some notes he plays much longer than other notes, and some notes he plays much shorter. What he plays is more like da 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 da. Okay, so I'll play it, and that's what I want you to listen to. Okay. So do you hear what I'm talking about? He speeds up, he slows down, he pauses, he breathes. And the question is, well, the first question is why? And the answer is actually, this is just like accepted to be a part of the performance practice of Western classical music. This is something that all performers of Western classical music do to virtually all pieces of music. And this is one of those things, it's part of how that an individual performer expresses themselves through music. And it's one of those things that everybody kind of knows how to do it if you've been trained in this style. And if you hear someone doing it well, like you know that they're doing it well, and you hear someone doing it poorly and you know that they're doing it poorly, yet there aren't any like written rules. There's not like a book somewhere that tells you how to do this, right? I studied music. I have a few degrees in music, and not once did anybody talk about this, but yet everybody does it. So it's one of those like fuzzy things. Everybody knows how to do it, yet nobody knows how to do it. And because it's one of those fuzzy things, it's actually one of those things that's like perfect for machine learning. Okay, so the people who built the flute robot that I showed you a moment ago wanted their robot to be able to do that. Okay, so I think you can probably imagine how they did this. First you need a data set. So they had, a real human flutist come in and play what looks like Tchaikovsky. And, so they sort of compare the durations that are written in the score to the actual length of time that he plays each note for. And they use that to train a neural network. And yeah, so this was a few years ago. So they were just using this regular, good old fashioned feed forward neural network. And I'm not 100% sure, even after having read the paper, exactly what they're putting into the input of the network. They just describe it as being nominal score structured data, whatever that means. But if I were to take an educated guess, I think for each note in the score, they put in the nominal written duration of the note, as well as probably some information about the pitch of that note. And then they probably do the same thing for several previous notes. Okay. And then what you hope to get out the other side is the amount of time that the robot is supposed to spend actually playing that note. So you put in what's written and you get out what the robot is actually supposed to do. And then you train it using the data from the human performance. Yeah. And so maybe one additional comment I can make about this is that I think if you were to do this today, you would probably use a recurrent neural network and not a feed-forward neural network, because recurrent neural networks are better at modeling sequences. And if I want to be a little more technical about that, I might just point out that a feed-forward neural network models a function. Okay, you put in X, you get out Y. You put in X 100 times, you get out Y 100 times. You'll never get, as long as you put in X, you'll never get out anything other than Y. Okay, whereas a recurrent neural network models a discrete dynamical system. So you put in X today, you get out Y. You put in X tomorrow, you might get out Z or something else. You can put in X 100 times and you might get a different result every single time. Okay, and I might say that music more closely resembles a dynamical system than a function, because at any given point in a piece of music, everything that is happening kind of depends on everything else that happened before. Okay. One other thing that they're doing with this flute robot, maybe I'll just be very brief about this. When you play the flute, you have to continually adjust what you're doing to stay in tune. Okay, it's not like the piano where you just press a button and the note comes out. You're blowing air into this thing, and you have to like continually manipulate like how hard you're blowing and kind of the angle at which your airstream is striking the edge of the flute there. And if you don't do that, you'll be out of tune. So they implemented this thing in the robot, whereby the robot listens to itself and is able to kind of adjust its control, so that the robot stays in tune. And this is one that I'm pretty sure they did this. They have some equations that tell them what to do. Like if the robot hears itself to be sharp, then there's an equation that tells it that it should like lower the pressure of its breath. But it's also interesting to think about how you might do something like this using machine learning. Like if you don't necessarily know the equations that govern how the robot's control parameters relate to the sound that eventually comes out. But in the interest of time, I think I won't go into any more details about that, but yeah, you can mull on that as you go to sleep tonight. And yeah, I have just a quick video of this robot playing. And again, this is another one. I couldn't find a video of the robot doing the exact thing that was described in that paper, but at least here's, some nice entertainment for you. think that's enough of that for now. Yeah, again, this one's on YouTube. You can find it if you want to see the rest of it. Yeah. Is there any questions so far, by the way? Okay, so maybe I want to talk to you about another robot. In this one, I might just start by playing you 30 or 45 seconds of a person playing. Yeah, so this instrument is djembe, and I'm going to show you some stuff pertaining to a djembe robot, but I just want to show you what this looks like when a person plays it. Yeah, okay. So there are a couple of points, I guess, that I want to make about this. First of all, in contrast to the other music that we've looked up until this point, this guy is improvising, right? So there's no like written score that he's memorized. He's just kind of making it up, on the spot. But having said that, he's also not just playing randomly, right? There's certainly a lot of like skill involved. And, he's drawing on a lifetime of cultural knowledge about how to play this instrument and what types of things are appropriate to play on the instrument and so forth. And it's interesting to think about how a robot could acquire something, analogous to this cultural knowledge that would allow the robot to improvise music that's kind of appropriate for a given musical style. And I think that's all I'm going to say about that regarding this robot, this instrument. But I'm going to come back to that idea probably in a few minutes, the idea of improvising and learning how to improvise. Okay. The other thing that he's doing here that I think is really interesting is he has like a myriad of different ways of striking the drum. Did you notice that? He has like probably 20 or 30 different ways of striking the drum. And every time he strikes the drum, like a different sound comes out. And I'll refer to these different sounds as timbres. Okay, so one method of striking the drum like produces a specific timbre. And yeah, so when you play the piano, like the notes on the piano are arranged by pitch. And when you play, you're kind of navigating the pitch space of the instrument. Well, this instrument doesn't really have pitch so much. It just has timbre. So when you play, you're kind of navigating the timbral space of that instrument. And so this is a robot that I built called Kiki. And Kiki is just a djembe robot. There's this drum here laying on its side, and then a 3.5 degree of freedom arm that can strike the drum. It's not that complicated. And this is intended to work sort of in conjunction with a human. So the question is like, how can the robot learn how to use timbre by listening to a human play? And I guess I might say that there are kind of three components to that question. First of all, like how can the robot learn to recognize which striking methods the human is using to strike, this instrument? Number two is like, how can the robot learn to produce specific sounds, or to produce, like how can the robot learn what striking method it should use to produce a particular sound? And then third, like, how can the robot learn how to improvise? Like once it has a repertoire of how to strike the drum, how does it assemble those striking methods into like an actual piece of music. And so I want to start maybe by talking a little bit about this first of those, stroke classification. In other words, if I strike my drum with a particular striking method and the robot's listening, the robot should be able to identify which striking method I used based on what it sounded like. Okay. And so how should the robot do that? Well, so even though in the video this guy was striking the drum with like lots and lots of different striking methods, there are really three that are kind of the core technique of this instrument. Like if you're just learning this instrument for the first time, you'll learn three methods of striking the drum. And those three methods all have like fairly distinct sounds. Like they're very easy, at least for humans, to differentiate between those sounds. And so how can the robot learn to recognize them? So suppose that you have like, a signal from a microphone, and this is like one instance of the drum being struck. So you can take the first 100 milliseconds of this, and you can compute some features on that. It's not so important. There's a book somewhere. You can look up in the book what features you can compute. Yeah, forget about that. So this is a bunch of individual djembe strokes plotted in some feature space. And so the axes here, so this axis is some measure of kind of how noisy the sound is. This axis is kind of how perceptually bright the sound is. And then one axis has to do kind of with how loud the sound is. And then each dot is like one instance of a djembe being struck. And the three colors, each color represents one striking method. Okay. And so when you do this type of analysis, what you hope to see are clusters. Like ideally, all of these strokes that were produced with the same method would kind of be in a cluster, and then there would be like nothing for miles around. And then, these blue things would all be kind of clustered over here. Okay, that's not exactly what you see here. However, at least like we've found like regions, like these different strokes lie in different regions of this space. Okay, so this is already like kind of a simple type of unsupervised learning. Like we've given the computer this thing and it's identified these regions. And now what you can do is use this to classify strokes. Because now if I play another stroke on my drum, and suppose the robot plots that, and it ends up over here somewhere, then you know that that stroke like belongs to this, it was produced by the same method as these nearby strokes. So I'm kind of describing nearest neighbor classifier, K nearest neighbors classifier. It's not important what classifier you use. You can use SVG, it doesn't matter. So I want to show you a video of how this works. And in this video, you'll see first, I train the robot by playing several examples of each method of striking the drum that I'm interested in. And then you'll see me play some other strokes and the robot will classify those. So I start by training the robot and training stroke category 0. So I'm striking the drum kind of in the center, and I'm just playing lots of examples of that, or a few anyway. And then stroke category 1 is like striking the edge of the drum. And then stroke category 2. And so let's see if the robot can now recognize these. Okay. Yeah, is that clear? Yeah, okay. So one thing I should be clear about is that at the end there, like if I strike the center of my drum, the robot knows that I played stroke category 0 because that's how I trained it. but it doesn't necessarily know that stroke category 0 corresponds to me striking the center of my drum. Do you see what I'm saying? So like I had to like explicitly program the robot to strike the center of its drum if it thinks that I played stroke category 0. I don't know, it's a little bit subtle. I don't know if that makes sense, but in this video, the robot doesn't necessarily know what striking method I used. It just knows what the category is. But having said that, because we have this kind of feature space, the robot actually can learn how to produce, like it can learn how it should strike the drum to produce a particular sound. Like if I want, suppose that I play a stroke on the drum and that stroke ends up here. Well, the robot should be able to strike its own drum over and over and over again until it figures out how to make exactly that sound. Like if the robot's listening to itself, then it should be able to adjust itself into making that sound. Like you can use some optimization thing or some search thing to search this space for a given sound. And so I also want to play you an example of that. So in this video, you'll see, first of all, you'll see me striking the robot's drum like over and over and over again, just playing lots of sounds on the drum. And that helps the robot kind of learn the size of the feature space. And then you'll see me play one stroke that I want the robot to learn how to match that exact sound. And then you'll see the robot strike its own drum over and over and over again to try to figure out what it should do to make that exact sound. It's hard to explain, but hopefully it'll be clearer when I play the video. Oh, and I should also point out that the robot is listening to itself through this microphone that's on the back of the drum. So I just play lots of random strokes. It just sort of calibrates everything. Okay, now I'm going to play one stroke that I want the robot to learn. So it's maybe not perfect, but at least it kind of works. Yeah, so by the way, the algorithm that I used to do that is simulated annealing. Frank, would you consider simulated annealing to be a genetic algorithm or no?
No, it's not population business.
No, it's just, you just search. That's all, you search. The arm has some control parameters and you nudge those control parameters. The robot strikes and then nudges the control parameters to see if it got any closer to the target sound. And you do that over and over again. That's all. Yeah, okay, that's all I want to say about timbre for now. Yeah, so I wanted to talk maybe just very briefly about guitar robots, just because on Monday, a few of you expressed interests in maybe doing something with this. And yeah, so lots and lots of people have built machines that play guitar. In fact, this seems to be actually quite a common, like kind of Arduino project or, Lego project. Like if you go on Google or YouTube, you can find pages and pages and pages of people who have built machines that play guitar in some form or another. However, okay, let me back up before I get to the however. I should maybe say that the one point is that I just think these things are awesome. I'm kind of in awe of human creativity and I mean, somebody built a Lego robot that plays guitar. Like, it's kind of awesome. And now is the however part. The however part is that none of these, as far as I know, none of these here or no guitar robot that I've ever seen has any, makes use of artificial intelligence in any way. So all of these devices have to be pre-programmed to play a given piece of music. Like normally you have a PC computer off to the side, you enter all the notes into some music software and you press play and you use this machine to play back the notes, but it just plays exactly what you tell it to play. And I could be missing something, but I'm fairly certain that all of these and every other one that I've ever seen over the course of, however many 10 years I've been looking into this, I can't think of one that uses artificial intelligence in a real, like, meaningful way. And so consequently, like, I think this is actually, like, could be a ripe area for new research if somebody wants to do something with this. I think, yeah, there are a lot of things you can do. And so one just kind of idea I had. So part of guitar playing is playing solos. Like your band is behind you and the band is playing some background music. And then the guitarist is supposed to kind of improvise something fancy. And this is another one of those things that's like kind of fuzzy, right? Like, when you hear a good solo, but at the same time, like there aren't really any strongly written rules about how you're supposed to do it. I mean, there's some music theory involved, but a lot of it is just like, it's fuzzy, it's up to intuition. And so, yeah, the broad question is just like, how can a robot learn to play guitar solos? And one thing that might be interesting to look at, I don't know if you guys have seen some of these neural network architectures like WaveNet and Sample RNN. These are fairly modern architectures that have been used. Well, they were all originally designed for speech synthesis. So they kind of output speech in the form of audio, like they generate audio one sample at a time. But because they deal natively with raw audio signals, they have a lot of applications for music and music related things. And so just one thing I was kind of brainstorming about, like, is it possible to use some variation on one of these network architectures to generate guitar solos? Like, you just put a microphone somewhere, you have a band that's playing music, right? You have an audio signal coming into the microphone and you just kind of pump raw audio into one of these models. And then what you want to try to get out at the other side are control signals that tells the guitar like what it should play, or tells the guitar robot what it should play. So yeah, I don't know if this is possible, but as far as I know, like nobody's tried. Or yeah, maybe they have. I don't know, if somebody knows of something, you should let me know, because I'd be interested to hear. It's almost inconceivable that nobody's done this, but at the same time, I can't think of any examples. Yeah, so if somebody wants to work on something like this could be really, really interesting. Okay. So I talked a little bit a moment ago about improvisation. And I want to look at this maybe a little bit more closely. And yeah, so maybe I want to play you another short video clip of some people improvising music together.
You join in?
Yeah.
Okay, so I think that's all of that I'm going to play for now. So yeah, there are quite a few things that are interesting that are going on there. Um, when you have two people, well, just when you have two people playing together, whether they're improvising or not, like one of the challenges is that those people have to have like a shared sense of time, right? They have to agree where the beat is in the music. And they also have to have a shared understanding of the structure of the music, particularly when they're improvising together. You know, the music is usually structured by chords, and both of the performers have to somehow know like what chords the other person is playing. And so in that case, it might be that they both just know that piece of music, and therefore they know what chords they should play. But also there are settings in which you actually look at a person's hands to figure out what they're playing. I think you do that more with guitar music than with piano music, but a skilled guitarist can look at your hands and know exactly what you're playing without, you know, ever having seen the sheet music for it before. So yeah, there's this question of like, if you're playing music together with a robot, how do you develop a shared understanding or a shared representation of time and structure of the music? And so I want to show you this, marimba playing robot that was built at Georgia Tech. And maybe I'll just quickly play you a little clip of this. Okay. And so I think you can hear and maybe also see based on some of the captions that, this robot follows his tempo and also like figures out what chords he's playing. But it's also, so maybe I should say a few things about how the robot does that. So you see he's playing not a regular acoustic piano, he's playing a digital piano. And so the robot actually isn't listening through a microphone. In fact, it's the case that every time he presses a note on the piano, there's like a digital signal, like kind of a serial message that gets sent to the robot. So in that way, without listening, the robot knows exactly what he's playing. And yeah, so you can't do this with just any piano. You have to use this special piano. And then also everything that the robot does is kind of based on his left hand. Okay, so the way that the robot finds out where the beat lies is because he plays exactly one note in his left hand per beat. Ding dong, ding dong. And the robot just measures the time difference between those notes. So the point is that you can't just play anything. You have to constrain the way, like you have to play in the right way so that this robot can kind of understand what you're doing. And yeah, similar thing for chords, like the robot knows what chords he's playing primarily based on his left hand. So this is another one I feel like is kind of ripe for more research. Like how would you do this in a way that doesn't constrain your playing? You know, how can the robot just like listen through a microphone and arrive at a shared representation of time and of the structure of the music? Okay, and so that's also something that could be really interesting to work on if somebody wants to do something like that. Yeah, so it's been, I think we're running out of time, so I think that's all I'm going to say about all of this for now. Yeah, so there's my contact info. I don't know, do you guys have any questions? Yes.
I'm kind of curious because you're working with using AI for improvisation, essentially. But all of these robots are also playing physical instruments. And doesn't that add an extra level of complexity that might not be completely necessary? Like you could have it just play a synthesizer or send MIDI to a digital instrument instead of playing physical instruments.
Yeah, I mean,
Just because it's cool.
I mean, yeah. So yes, and I mean, yes and no. Like, if your goal is to just like synthesize music, I mean, yeah, why not just simulate it on your computer or whatever? I mean, certainly a valid point. And yeah, lots of people have done things like that. I guess I have two responses. One is that like, actually, I have several responses. One is that, you know, some people consider like live acoustic sound to be like so far superior to what you can get over your laptop speakers that it's just, you know, like the way you interact with live sound is different than the way you interact with computer synthesized sound. Yeah, and so there's also the argument that there are other things going on. I mean, one of the things that I actually really want to study in my own research, I haven't done much yet, but I really want to, is like studying the interpersonal communication. Like, there's kind of, when human musicians play together, there's like all of this nonverbal communication. You're making eye contact, you're moving your body in a way that communicates something about what you're doing. And yeah, I mean, maybe you could make a little animated avatar or something that does that. But yeah, I think there are valid reasons also for studying that on like a real physical robot. Yeah. Any other questions? Yes.
I was just wondering, in the case of improvisation, what would happen if you didn't give the robot any input? If you just gave it a key and told it to play?
Oh yeah, so yeah, so you can certainly like train models that do this. A lot of these models, like you put one note in and you get one note out, but you start by just putting in something random, and then you get one note out, and then you feed that note back in to the input. So then you get this feedback thing where you generate more and more music. Yeah.
All right, super. So let's all thank Mike for the talk.